Imagine you're floating in the vast emptiness of space. Stars twinkle like distant diamonds, galaxies swirl in breathtaking colors, and you, my friend, are completely stark naked. Now, before you get any ideas, this isn't some new age relaxation technique or a scene from a low-budget sci-fi flick. This is about the reality of what happens when a human body is exposed to the unforgiving vacuum of space. Spoiler alert, it ain't pretty. So put on your hypothetical space helmets, folks. And let's dive into the wild ride that is surviving or not the cosmos au naturel. Because understanding the dangers of space might make you appreciate the cozy confines of our little blue planet a whole lot more. Let's get one thing straight right off the bat. Your head will not explode in space. Yeah, I know, total buzzkill. Hollywood has fed us a steady diet of dramatic explosions and instant freezing when it comes to space exposure. But the truth, my friends, is a bit more nuanced. While not as visually spectacular, the reality of what happens to the unprotected human body in space is a fascinating study in the limits of our biology. You see, our bodies are remarkably resilient machines, evolved over millennia to thrive within the very specific conditions found on Earth. We take for granted the fact that we're constantly bathed in a sea of air pressure, a pressure that keeps our insides, well, inside. In the vacuum of space, that pressure disappears and things get a little messy. The first thing you'd notice is the lack of breathable air. No big surprise there, right? But it's not just about the absence of oxygen. The sudden decompression, the rapid change in pressure from our atmosphere to the vacuum of space, that's where the real trouble begins. Imagine opening a sealed can of soda. That fizz that erupts? That's the gas, forced out of the liquid because of the pressure change. Now imagine that happening to the air inside your lungs. Not a pleasant thought, is it? This rapid expansion of air can cause serious damage, even rupture your lungs if you try to hold your breath. The best course of action if you ever find yourself in this unfortunate situation is to exhale as much as possible. It won't make breathing in space possible, but it might buy you a few precious seconds. Remember that whole pressure thing? It affects more than just our lungs. See, our blood, like any other liquid, has a boiling point. Here on Earth, at normal atmospheric pressure, our blood happily stays in liquid form. But in space, with no pressure to speak of, the boiling point of liquids drops dramatically. This means that the fluids in your body, including your blood, would literally start to boil. And no, I'm not talking about overheating like a pot on a stove. This boiling would happen at body temperature thanks to the lack of atmospheric pressure. Alongside this, you might experience something called ebullism. Remember that soda can analogy? Well, now imagine that happening to the liquids in your skin and tissues. Not exactly a recipe for a good time. Section 5. To freeze or not to freeze? That is the question. Now you might be thinking, but Neil, wouldn't I freeze to death in the icy cold of space? It's a common misconception, fueled by countless movies and TV shows. And while space is undeniably chilly, hovering just a few degrees above absolute zero, freezing to death would be the least of your worries. You see, heat transfer in space works a little differently than here on Earth. Here, we lose heat through conduction. Touching something cold, convection, heat being carried away by air or water, and radiation. In the vacuum of space, conduction and convection are basically non-existent. That leaves radiation, a much slower process, as the primary way for your body to lose heat. So yes, you'd cool down eventually, but not before other, more pressing issues took center stage. So, how long could you actually survive this cosmic carnival of horrors? Surprisingly, not as long as you might think. You'd probably remain conscious for about 15 to 20 seconds, depending on your individual physiology. After that, oxygen deprivation would lead to hypoxia, causing your brain to shut down. But here's the kicker. Your heart would actually continue beating for a few minutes after your brain gave out. Why? Because unlike the brain, which is a greedy oxygen hog, the heart has its own internal pacemaker and a small reserve of oxygen. This means that technically you wouldn't die instantly from space exposure. Of course, technically is a relative term when you're talking about being exposed to the vacuum of space. Now let's say, hypothetically speaking of course, that you were lucky enough to be rescued from your impromptu spacewalk. What kind of shape would you be in? Well, that depends on how long you were exposed and how quickly you received medical attention. If you were pulled back inside within a minute or two, you'd likely recover with minimal long-term effects. There might be some bruising, maybe a case of the bends from the rapid pressure change, but nothing a little TLC and maybe a hyperbaric chamber couldn't fix. But any longer than that and the damage, unfortunately, becomes more and more severe. It's a testament to the incredible adaptability of life that we can even contemplate surviving, even for a short time, the harsh realities of space. Think about it. Our bodies, these fleshy vessels that evolved to walk on land and breathe air, can withstand the pressure of the deep ocean, the thin atmosphere of high altitudes, and even the bone-jarring forces of a rocket launch. But space, my friends, space is a whole other beast. It's the ultimate test of our physical limits, a stark reminder of just how delicately balanced our existence truly is. And while our ingenuity has allowed us to explore this final frontier, it's important to remember that we are still bound by the laws of physics and the limitations of our biology. So the next time you see a movie where someone gets sucked out of an airlock without a spacesuit and explodes in a shower of gore, remember, it's not quite that dramatic. But that doesn't make space any less dangerous. It's a place of extreme temperatures, intense radiation, and of course, a distinct lack of breathable air. So let's leave the spacewalking to the professionals, shall we? They've got the training, the equipment, and most importantly, the spacesuits to keep them safe. As for the rest of us, we can marvel at the wonders of the cosmos, from the comfort of our atmosphere-ensconced planet. And hey, maybe we can leave the birthday suits for more appropriate occasions.